Hello class, it's Mr. Kablan here again, and I'm here to present the final lesson for chapter 9, and we are strictly going to be dealing with word problems involving surface area and volume of the shapes we have covered prior to this lesson here. All right, so one thing you should have handy, again, are two things actually. Okay, make sure you have your formula sheet handy just as a quick reference, okay, and please make sure you have a calculator as well, again, because it's just so you can get your hands ready in terms of what kind of calculations and what steps we need to perform in order for us to get the answers we are looking for. All right, so let's get straight to it. So I said before, today's lesson is going to deal strictly with word problems. Some of them are easier than others, some of them are harder than others. So what's important, again, when we're looking at word problems, again, is to read the question very, very carefully, especially when it comes to the units. And the reason for that is because when you're looking at units, and we saw this with the lesson dealing with the cylinders, the fact that all units have to be the same. Okay, so when we're calculating surface area or volume. Okay, so just be very careful when you're reading the question to see what the units are and what the units for the final answer should be here. All right. And basically the problems we're going to look at in today's lesson will be comprised of two or more different shapes, and we need to figure out what steps we need to do in order to answer the question that is being asked for us here. All right. And what's important, again, not only are the actual calculations, but the steps involved in order to come up with a final answer for each one. Okay, and in some cases here, it is going to be an extension to using to surface area and volume problems, and some of the problems, believe it or not, just require just a little bit more critical thinking than what we have seen up until this point here. All right, but again, after this lesson, you should be able to go through it and navigate these kind of problems. So the first thing we're going to do here is we're going to look at the volume of a pill. And with the volume of a pill over here, it actually consists of two shapes here, a cylinder, okay, and a half of a sphere on each end. Okay, so what we want to do here is to calculate the total volume of the sphere here. Okay, now as you can see, just double check the units. Okay, our units are all in millimeters, so we don't need to do any conversions. So we're going to get straight to that. Now remember, we are dealing with two shapes here. So quite often the common question is, well, how do we know if we have to add the volumes or subtract them? Now a capsule, as you can see, is one entire shape. Okay, we're not removing any shapes, we're actually grouping it and piecing it together. So what we need to do for this is actually calculate the volume of both parts, okay, and then from there, adding them together. So the first thing we're going to do here is we're going to calculate the volume of the cylinder part first. Okay, so we're going to use the formula pi r squared h. Now just double check what we have here. You notice the 3 millimeters is the entire distance across of the circular part of the cylinder there. So the first thing we need to do here is we need to take this diameter and we need to change it to radius just by dividing this by 2. Okay, so that's step number 1. Okay, and once we have that, okay, even though this pill is sideways, the height of this pill here is going to be 20 millimeters. Okay, so that's the part that you need to see for that one. Okay, all right, and from here we're going to put the numbers in. Okay, and then from here simplify. Okay, now I kept it nice and simple here. Just keep in mind the 20 millimeters. Just ignore the arrows there. Just keep in mind we're just looking at the cylindrical part. Okay, and then from there for step number 2. Okay, we have to now calculate the volume of 2 half spheres. Now let's just think about this for a moment. Okay, if we have 2 half spheres, what do we really have? Well, yep, you guessed it, we get a full sphere. All right, so the way we're going to do that is we're going to use just the basic formula for the volume of one sphere and put the numbers in. And we already have the radius here, so all we're going to do here is replace the r here with 1.5, okay, and then evaluate. All right, so now that we have the two volumes there, okay, we just need to add those two volumes together. So when we add those two volumes together, gives us a total there of 155.43 cubic millimeters. All right. Okay, so again, for that one there, again, it was again, nice and one to start us off with. Okay, we we figure out what information we have and then put it into the correct formulas and then think of a plan to solve for the final answer. In this case, what we have to add. All right, so the next thing we're going to do here is we're actually calculating the surface area of the barn. Now this one over here is going to be a little bit tricky here, and it does require multiple steps here. So again, please be patient with this example. And what we have to understand here is that with the barn, okay, it says the exterior walls of the barn to be painted, and the barn is in the shape of a rectangular prism with an isosceles triangular prism for a roof. And what we want to answer for this question here is we want to first find the total area that's to be painted. Now let's think about this for a moment in terms of what exactly is going to be painted. Now starting off at the bottom, okay, it's only saying that we only want to paint the walls. Okay, so if you're thinking about a rectangular prism in terms of the formulas that you have there, we can't use those because those formulas are assuming that with a rectangular prism, okay, that all 6 faces are there. Since we're dealing with only the walls here, we're only looking at the front and the back. Okay, so those are the two rectangular faces in the front. Okay, and the two rectangular faces which make up the sides. So we can't use the formula straight out. We actually have to do each calculation separately. Okay, same thing with the triangular prism here. We have the two triangular faces in the front. However, when it comes to the rectangular faces, we're only looking at the roof part, okay? Because the floor isn't going to be painted, okay? So we actually have to do each calculation separately, okay? So that part is actually going to be the part. It's not difficult. It's just a little bit long here. So again, just be patient. So starting off with the first part here, we're going to calculate the rectangular front, okay? As you can see, and the way we're going to do that is to use the basic formula for the area of a rectangle, which is on your formula sheet on the left side there. And since there's 2 faces, we're going to multiply that with 2. Okay, and by doing that, okay, again, the length and the width here, the length here is 25, the width here will be 10. We're going to take those numbers and multiply them all together, and that gives us a total of 500 square feet. So we've dealt with the rectangular face, specifically the 2 rectangular faces in the front. Okay, so the next part for the bottom here, we're going to take the 2 side faces and use the exact same formula. Okay, this time the length here will be the 55 and the width here will be the 10. So when we multiply those numbers together, that gives 1,100 square feet. So we've taken care of the bottom part, all right? So the next thing we have to do now is we now need to calculate the area of the triangular front and back here. Okay, and all the measurements are there. Now what we have to do here is to take the formula for the area of one triangular face, okay, which is base times height divided by 2, and then multiply it by 2 because there's 2 faces, okay? So what we have here, the base here will be 25, okay, and the height again is the vertical height, which in this case here is the 8. Okay, when we put those numbers in, okay, again, I'm just going to break this step by step first, okay, and you can see that the final answer here is 200 square feet. Now, if for those that didn't see it right away, we have 1, 2, 3, 4, 5 steps over here. Well, 4 calculations specifically. Okay, we can actually reduce this into 1. Okay, if you take a look at the 2 2s on the right side here, okay, and I'm going to use just a red pen here. Okay, when I multiply this 2 to the base times height divided by 2, these 2 2s actually cancel out. So, for example, if you just took the 25 times 8 here and multiplied these two together, okay, you would still get the same. You would still get the same answer there. All right. So I want you to see again mathematically. Okay, there are different ways to do it. I'm just presenting you with another way to see it, just in case some of you saw that right away. Okay. All right. So we've calculated the area of the triangular faces. Now we need to take a look at the rectangular faces here. So as you can see, okay, I've highlighted it accordingly, and we're going to use the formula length times width again. So the length here is going to be the 55, and the width here will be the 14.8. Okay, so when you put those numbers in, okay, we get a total there 1,628. Now that we have the area of each face, we just need to add all those together. All right, and that's going to give us a total there of 3,428 square feet. Okay. So notice what we did here. We calculated the total area first, because now what we have to do there is take this answer to answer the following question. So the next part of the question over here is using what we had from the previous answer, and I've moved it to the left there. It says here 1 gallon of paint will cover 900 square feet. How many gallons will be required to paint this barn? Okay, so basically what the way we're going to look at this, we're just going to think about this logically, is that we need to cover 3,428 square feet. Okay, and then this question is asking us how many gallons do we need in order to cover that amount. Well, it tells us that 1 gallon, okay, covers 900 square feet. So the fastest way to do this here is to take the total the total square total surface area and divide it by how much the 1 gallon of paint will cover. Okay, and the way we do that again is to divide those two numbers into each other. So what we will have here will be 3,428 divided by 900. So this is going to tell us that we will require 3.8 gallons of paint in order to cover this barn. All right. So you notice that this is now the extension part of the question, is just understanding the steps required to answer to actually answer the question that's being asked here. Now, as I said before, when you're looking at the surface area for this one, you don't automatically jump to the formula sheet. Think about the fact that with surface area, you're looking at the area of each face. Okay, in some cases, not all faces are going to be there. Okay, so just keep that in mind when you're looking at these type of problems here. All right. Okay, so the next one we have here is a combination of a rectangular prism and cylinder. So it says here, a rectangular piece of wood has a length of 8 inches, a width of 24 inches, and a height of 1 inch. Okay, it says here, 12 cylindrical holes, each has a radius of 2 inches and a height of 1 inch. Okay, and they're drilled through the wood. Okay, and what we want to do here is, and ultimately, is to figure out what the volume of the wood is after it's drilled. But before we do that, what we have to do here is to find the volume of the wood all together in one piece, and that's exactly what we're going to do in the first step here. So the way we're going to do that, we're going to use the formula length times width times height, or LWH, and our L here is the 8, our width here is a 24, and the height here will be the 1. Okay, so when we put those numbers in, okay, the volume of the piece of wood there will be 192 cubic inches. Okay, so that's step number 1. Now keep in mind what we want to do here is we're taking cylindrical holes and we're now drilling it out. So our next step here for part B is actually 2 separate steps here. It says, what is the volume of the wood after the holes were drilled? Okay, keep in mind that these are cylindrical holes, or holes that are cylinders, and we have 12 of them. So what we have to do here is we need to use the formula for the volume of a cylinder, which is pi r squared h, okay, and then multiply it by 12 like this. And the easiest way to do it is to set this up accordingly and put the numbers in. So we know that the radius here is 2, okay, and the height here is 1. And all we're going to do there is replace those numbers in for the correct variables here, okay? Now from here, okay, when you put the numbers in carefully in your calculator, okay, if you put in 12 times, open up a set of brackets, pi, open up another set of brackets, 2, close the brackets, okay, raise the exponent 2, and another set of brackets, put in 1, and then close it again. Again, it's going to look a little bit different in your calculator, okay, but you should get an answer that is approximately that. All right. Now, last but not least here, since we're drilling it out, okay, what we're going to do now is to take that volume and then subtract it from the volume of the rectangular piece of wood there. Okay, and by doing that, okay, that will give us our final answer for this question. All right. So in this case here, we had to subtract because, again, you're drilling pieces out of another piece of wood, another object there. So in this case over here, again, that's just the way to determine whether you add or subtract. Okay, so in this, since we're removing something, that's why we have to subtract in our final step there. All right. Okay, so that wraps up this chapter. So continue on working on with the rest of the review package there. Okay, and get ready for the tests. Okay, and I'll see you in the next one.